We'll take our plates out. There's the vanillin. You can see that the vanillin is staining quite dark brown. The tranexamic acid is not staining, so that's a way we can distinguish the two. Right. So you can see that the co-spot also has a little vanillin. It was just buried underneath the real big streak for the tranexamic acid. Right. So that's indication that that's mostly vanillin with, well, I mean, tranexamic acid. Well, this is tranexamic acid with a little vanillin. And you can see that wherever the triethylamine was, it's staining the whole plate dark. But what I wanted to point out is this top spot here, we weren't quite sure what the identity of that was. Now we are, because vanillin stains and tranexamic acid doesn't. So the fact that those stained with the iodine means that those are vanillin. And that's our contaminant in the tranexamic acid. So when we purify it, we're going to want to choose a method that's likely to separate those. This will fade a little bit over time. You can't really see the tryptamine spots as well, but I can tell that they are a little bit darker inside the oval than they are outside. But when you have triethylamine in your solvent mixture, the iodine is not a great staining method. Triethylamine sticks so hard to silica that it really won't evaporate very readily. You need to just let that go a little longer. And I'll put these away while I'm waiting. And I'm going to put my standards back where they came from. And I can set these back. I'm done with those for the day. Pipettes can go back by the balance. And that's good enough. There's my solvent front. I usually use a beaker to just put all my waste in so I don't have to keep walking back and forth to the waste container, and then I can take everything over there at once. So that's a little better. My tranexamic acid is still streaking, but not as badly. And then I've got a very faint spot there. You can hardly see it, but I think it'll probably stain. So this will allow us to get better RF values. And we'll stick that in the iodine chamber and let it do its thing. The tranexamic acid won't stain, but the impurity probably will. And while we're waiting for that, I'll go ahead and put this UV lamp back in the stockroom. Can dispose of the solvent. Organic waste. And methanol, methyl acetate dichloromethane. Most of those solvents are all on there. That can just evaporate as well. These are some of the TLCs that I ran over the summer. So you'll see that the vanillin purified by a column. So that's it. Just a little longer. I'll put those away another day after they really evaporated. And I will, of course, take a still picture of this and upload it so you can pull it up on your screen and actually measure the distances to get your RF values. And I'm going to let that tryptamine one fade a little bit more so you'll actually be able to see the dark spot. These gradually fade over time, so if I leave this long enough, that iodine spot will be gone. That should be good enough. So I think you can see that this is mostly tranexamic acid. There's vanillin there, but that spot is really not staining very dark. So we've done a much better job at getting the tranexamic acid out fairly clean away from the vanillin than we did about getting the vanillin away from the tranexamic acid. And you can tell that from the masses as well. So that's it for TLC. Stop this video.